In the first question, we have to find the ratio in which the y-axis divides the line segment joining the points 6, -4 and -2, -7. We also have to find the point of intersection. And in the second question, we have to show that the points 7, 10, -2, 5 and 3, -4 are the vertices of an isosceles right triangle. In order to solve the first question, we will use section formula. This formula suggests that when 2 points, let them be A and B, divides a line segment into a ratio of m1 is to m2, therefore the point which they are intersecting, its values can be represented by this formula which is mentioned here. So using section formula, we are provided that it will touch y-axis, therefore the coordinate on which it will be intersecting will be 0, y. Now putting the values of both the points provided into the section formula, we obtain these two values. -2k plus 6 upon k plus 1 is the value of x coordinate, and -7k minus 4 upon k plus 1 will be the value of y coordinate. As we know, the x coordinate of the line intersecting at y-axis will be 0. Therefore, we equate the x-axis value to 0, which gives out the value of k is to 3. Therefore, the ratio comes out to be 3:1. Now, further solving for the point of intersection, we put the value of k into the y point of the section formula, and which gives out the value of y point to be -25 by 4. Therefore, the point of intersection comes out to be 0, -25 by 4. In order to solve the second question, we are provided with three coordinates, and we have to find whether the given triangle is isosceles right triangle. As first of all, we will solve for the distance formula for all the 3 points, which gives out the distance of two of the lines to be root 106, and the third line comes out to be root 212. So in a triangle to be a right angle triangle, it must satisfy Pythagoras theorem. Now we will apply the Pythagoras theorem on both three of these points, and as we can see, it is completely verified. Therefore, and as the value of two of the sides are equal, therefore it is a right angled isosceles triangle.